Everything around us, from the chair you're sitting on to the air we breathe, is made up of tiny things called atoms. Atoms are like the building blocks of everything in the universe. Think of an atom like a miniature solar system. In the center, we have the nucleus, which is like our sun. The nucleus is made up of even tinier particles called protons and neutrons. Protons have a positive charge, kind of like the plus sign on a battery. Neutrons, on the other hand, have no charge. They're neutral, just like their name suggests. Whizzing around the nucleus are even tinier particles called electrons. They have a negative charge, like the minus sign on a battery. These electrons are constantly moving, just like planets orbiting the sun. Now let's talk about nuclear fission. Don't worry, it's not as scary as it sounds. Fission is simply the process of splitting an atom's nucleus, kind of like splitting a cookie in half. When the nucleus of a heavy atom, like uranium, is split, a tremendous amount of energy is released. It's like releasing the energy stored inside a tightly wound spring. But how do we split an atom? We can do this by hitting the nucleus with a neutron. Imagine throwing a ping pong ball at a stack of bowling balls. When the ping pong ball hits, it can cause the bowling balls to scatter, releasing energy. This energy release is what makes nuclear fission so powerful. So how do we harness this incredible energy from splitting atoms? That's where nuclear reactors come in. Nuclear reactors are like giant kettles that use the heat from nuclear fission to boil water and produce steam. This steam then turns turbines, which are like giant fans, and the turbines generate electricity. Think of it like this. The heat from splitting atoms is like the heat from a stovetop. This heat boils water to create steam, just like when you boil water for pasta. The steam then turns the turbines, which are connected to a generator that produces electricity. It's a clean and efficient way to generate large amounts of electricity without producing greenhouse gases. Nuclear energy is important for our future because it can help us combat climate change. Unlike fossil fuels, nuclear power plants don't release harmful greenhouse gases into the atmosphere. Nuclear energy is also a reliable source of power. Nuclear power plants can operate continuously, providing a steady stream of electricity, unlike solar and wind power, which depend on the weather. While nuclear power does come with some risks, like the potential for accidents or the challenge of storing nuclear waste, these risks can be managed with careful planning and advanced technology. Nuclear energy has the potential to provide clean, reliable energy for a brighter future. It's an important part of the mix as we explore sustainable energy solutions for our planet.